Okay, next we'll talk about the closure property, and I'll state the property and write it down, and then I will elaborate on it a little bit. It simply says this: if a and b are real numbers, then a plus b is a unique real number. If a and b are real numbers, then a plus b is a unique real number. And the same is true for multiplication. A times b is a unique real number. Okay, and it doesn't sound like that's a very big deal. All it's saying is that if you add two numbers, you end up with a real number for an answer. And if you multiply two numbers, two real numbers, then you end up with a real number for an answer. But it also says that the sum of two numbers is unique. That means there's only one number that is the sum of any two other particular numbers. And the same thing is true for multiplication. There's only one real number that is the product of any two particular real numbers. We call this the closure property. A mathematician would say that the set of real numbers is closed over addition and is closed over multiplication. And what that means is that if you're doing addition or you're doing multiplication, then real numbers will do the job. If you add two numbers, then your answer will be a real number. You won't end up with something outside the set of real numbers. And same thing with multiplication. If you multiply two numbers, you typically, especially if the numbers are big, you typically get a bigger number. But you're not going to get something that's so big that it's suddenly somehow outside the set of real numbers. The set of real numbers is adequate to the task if you're adding or multiplying. So the mathematician would say the set of real numbers is closed over addition or closed over multiplication. And the point here to understand now is that not everything is. Addition and multiplication work this way, but not everything does. Square roots, for example. Here's a square root. What if I take the square root of -7? -7 is a real number, but square rooting it doesn't give me a real number. The answer here is not anything that's on the number line. You can't find any number anywhere here that when you square it will give you -7. The answer to this is not a real number. It's literally off of the number line. It's something that we call a complex number or an imaginary number. And we touch on those a little bit toward the end of this course, and we really get into that in the Algebra 2 class. For now, just understand that addition and multiplication operate according to the closure property. The set of real numbers is closed over addition and multiplication, but not everything is. Now, we've talked about the commutative property, the associative property, the transitive property, and the closure property. And here are some simple examples. We're told to name the property illustrated. And the first one is mz equals zm. Well, this is the commutative property. And specifically the commutative property of multiplication. Okay, the second one, 12 plus 14 plus 72 is equal to 12 plus 14 plus 72. And even without adding those up and getting an answer, I know that's the case. I know that 12 plus 14 grouped and added to 72 has to be the same as 12 plus 14 and 72 added together. That's the associative property. And then the third one here, if a equals k and k equals 7, then a equals 7. That's an example of the transitive property. Now these ideas should all make sense, all of these properties of numbers that we've gone over. And if these ideas are obvious to you, then that's good. If you understand these ideas, then you understand the basics of how numbers work. And if any of these ideas don't make sense, then you need to get those straightened out before we continue with the course. These are basic foundational ideas that we assume to be true as we go through the course developing the rest of the theories of algebra that we'll work through in this course.